So I'm going to be talking about some of the futures around cognitive computing and the use of data in changing society, really. That's what I'm going to be talking about this evening, which is cognitive computing. Man-machine symbiosis, as was defined by Joseph Linkleiter in 1960. As long ago as that was when that first paper came out saying that computers, man-machine symbiosis, the combination of the two. So computers were good at solving problems, but then they, in a formulaic way, but they could start to solve thinking in a formulaic way, and together with the combination of man and machine could address things they'd never been able to do. It's very interesting because at the time, obviously, there was a 1956 artificial intelligence was first referenced in Dartmouth in a conference in New York. Following up, 1950 was when Alan Turing raised the Turing test. So there's a lot of thought about could machines actually exist in their own singularity, as it is sometimes called, okay, or often called. You know, would they be able to develop themselves and continue? It's a long time ago, okay? It's a long time ago, and it's a long vision of what we're actually coming to today. And we've gone through several phases, and some of you, like me, have been through them. I don't think any of you have been through the tabulating phase. If you can, put your hand up, and I'll be really impressed, okay? Well done! Okay, I remember seeing them so in a history museum. The next, and that was really the 40s and 50s, and they were mechanical machines, which were basically punch card driven with wires. I did try and program one once and failed abysmally, and just either took cards, added up, and punched out other cards. Very, very simple, but incredibly efficient machines. Made a real difference to the businesses that they were supporting at the time. From the 50s, you start to get programmable machines, and that's when you start to get logic. You start to get deterministic machines. Machines that have a program which take structured data and produce a result based on a set of rules and a result you can expect, anticipate, and know. And that wave of computing continues. And that's really what a lot of our back office systems and our systems of record, if you like, are today. And continue, and will continue to be programmable machines. What's different is in that period after probably about 2011, we start to move into what we would describe as a cognitive period, where you are able to take unstructured data, and you are able to take data in motion, as well as data at rest, and you are able to start to gain insights from that data, using analysis, cognitive analysis, against those records. And you're able to make suggestions. You're able to make, and if you term it as probabilistic computing, it's probable that, not it's definite that. So I'll give you a quick example. If you take Watson from Oncology, Watson is our cognitive system. It played Jeopardy in 2011 and won, fortunately. And that was our 100th year, our 100th anniversary. And in February of that year, we stuck up Watson on the American television to play a game against the two best Jeopardy players. And we put a machine to play that. And Jeopardy is quite a hard game. It's a very hard game. It's not easy to do. We'd spent 5 years preparing that, okay? And it came down to one evening, 30 minutes, and a game on television. And Watson won. And it did it because it was very good at natural language support, and it was very good at Q&A, and being able to understand a large amount of data that was satisfied that type of system. We've obviously taken that on. Since then, we have added something like 24 additional services you can get out of Watson with something like 50 different analytic technologies. One of the first uses, and this is where making IT good for society comes in, is oncology, an oncology advisor. And what that does is sitting alongside, and this is, you know, IT typically in my lifetime has been behind the specialist, behind the business, providing service to the client through the business. With Watson, an oncology advisor, we stand shoulder to shoulder with the doctor. Okay? That doctor could be it could be in Africa, it could be in Asia, but it's actually getting the experience and the knowledge of Sloan Kettering. Okay? But it's not taking the responsibility of the doctor. It's making recommendations. So from its huge amount of information, which is regularly being updated and ingested into the Watson machine, the doctor can feed in, the oncologist can feed in blood samples, can feed in all the other associated testings, MRI scans now. And from that, Watson will give a probabilistic response. It's 70% likely, having looked at all this set of information, all these papers, all these new studies, all these tests, all these different cases that we've looked at across the world, that we've ingested into, they've ingested into Watson, there's a 70% chance, 80% chance, 60% chance that this treatment is good, this treatment is good, this treatment is good. Most oncologists would not be able to do that on their own. They just wouldn't have the time to read the papers, study the results, look at the different tests, and do things like that. So Watson stands up in a room with the patient, the doctor, the trainee nurse, whoever else it is, as a person around a table, and this is the view of Sloan Kettering, and provides cognitive support to the decision those people are taking. It's not artificial intelligence. It wouldn't pass the Turing test. We're not trying to do that. It's augmenting the capability of the professional. Augmenting. And that, I think, is what, when we say team to win, is exactly what we'll be doing with different professions, different companies, different people in different companies, and advancing society, advancing the health of society, advancing the efficiency of society, advancing knowledge in society by standing alongside those professionals who really understand. So we augment what they do. And the technologies in that start to become very exciting. So vision, recognition of faces, recognition of style of face, recognition of attitude, recognition of the person if they're famous, offered as an API for people to develop programs on through Bluemix. Up to 50 different services offered through that platform, so you can write your own cognitive applications or applications using cognitive, bringing them to the front end, enhancing your engagement with the client, enhancing your engagement with the customer, with the professional, with whoever else it is, by bringing in all that amount of data. We know, Gartner says, data will increase 800% in 5 years. 80% of that will be unstructured. So all that programmable stuff, all those things I loved, which were database records, and I could identify within which particular byte was the most important thing, that goes away. This is about text. It's about sound. It's about vision. When you start to include those things, you start to understand the world, and you start to understand and help people making decisions. Okay? We have the computing capability to do that. We have the bandwidth to do that. We have a host of things which enable to support. And we now have, with the result of all sorts of investments in technology in all companies, along with open source, which makes a huge difference in provision of this type of thing, then you end up with people being able to really have someone or something, and I use someone, it's not artificial, a machine, Watson, sitting, advising. Take that a stage further. We talk about the Internet of Things. I think many of us understand, or hope to understand, what that means. Trillions of devices merrily chattering away, telling us exactly what their state is, what they're looking at, what they're potentially smelling, what they're feeling, all the time. Deluging systems all the time. Well, Internet of Things, Internet of Emotions, as you look at a smartphone, Apple have just bought a company which can analyze people's faces and their emotions, okay, and see what it's doing, feed that back in for better client service, okay. Feed all that in, and you start to say, Maybe there's just too much for everything coming in. Maybe we need to have the Internet of Things or cognitive distributed. Okay? So you may want to put into the smartphone many of those capabilities that you currently reside in large distributed or mainframe systems or large systems back in HQ. So one of the things that we're looking at and is coming is a new form of chip architecture. We've been living with, and most of you will have experienced and loved, the von Neumann architecture. Okay? Memory, CPU, input-output bus, that's the way it works. And it has worked since he declared it just during the war. And that's how machines have been made to date. A clock which ticks, continuously using energy, continuously looking for instructions to perform. Probably only used 5% of its time in things like PCs or things like that. That is too energy efficient and too expensive to put in devices like this. But imagine trying to change that architecture. Imagine trying to make a chip which starts to have the characteristics of a brain. So neurons, synapses, neurosynapses, so little connections of the two. Imagine trying to do that, and imagine trying to make a chip which doesn't work in the same way, isn't a calculator, doesn't deal with structured data, but spots images. Can see something. Imagine a camera which doesn't transmit anything unless it sees a lorry moving or a car moving. So it doesn't disturb the central system, doesn't disturb it with streaming everything that, possibly watching the grass grow. Simply is programmed to look for an image before it transmits. Imagine that level of control, that level of intelligence, that level of ability to identify and really pick up nuances happening in your network. Then you think of our North Star chip. When you think of a chip, which today is our biggest ever chip, requires a completely different programming model, but which uses the same sort of energy as the brain uses, which is tiny, which doesn't have a clock, which doesn't use energy all the time, but which reacts like the brain does to specific activities and things it's programmed to look for. Imagine that, and we have that today as rather a large item, over 5 billion circuits on 5 billion integrated chip, I'll get that right in a minute, 5 billion bits on the chip. Imagine that shrunk and placed in a camera, security camera, right? No need to stream loads of data up. Just stream it when you see something appearing in that space. No need to use loads of energy, battery power, or anything else like that to do it. Just think of it when you can do that. So you start to see cognitive, not just being held in the way I've described it, so being able to have an API with loads of data streaming in, and you can do sentient analysis, you can do personality analysis, you can do risk analysis, you can do all the things you want to do on huge amounts of data coming in. But imagine being able to do that at the edge of the network in lots of different places. Then you start to understand, from a business perspective, you're not just doing oncology, you're starting to understand movement, you're starting to understand and help in security, you're starting to understand and do things like health and safety applications. So something we're doing at Haifa, which is our research lab in Israel, is a health and safety application, which is based on knowing everything about the person who is working in a particular area. Knowing his location, knowing his health, knowing whether he's falling over or standing up, knowing whether he's got a helmet on, knowing whether he's conforming to everything that you expect him to do, provide him with a better healthcare environment. And if he does fall over, alerting people to come and immediately come and service him. Imagine that, take it to a smarter city, and have a dashboard. A dashboard that the mayor looks at, which covers crime, covers traffic, covers water, covers electricity, covers all those items. And he can drill down and see what's happening. Imagine in that space, the police being able to anticipate when a crime is likely to happen, based on history, based on streaming, based on things. So, imagine being at the place of the crime before the criminal, right? Are these AI or are they cognitive? Actually, they're cognitive, okay? And with the amount of data you have and the amount of ability to process it with the new systems and with systems that are coming, you have, for the first time, you illuminate in data meaning. And you can take decisions on that. So, when you think of artificial intelligence, and you think of the debates, and you think of what was called the AI winter, which took place various times up until 2011, as people invested in AI and then disinvested as they were disappointed in the results. And the point about singularity, the point at which machines no longer need us, okay. But think today of cognitive. Think today of augmenting the professional, whether they're in a call center, whether they're a policeman, whether they're a doctor. Think of whether they're a risk advisor, whether they're an investment advisor. All of those things you can do, and you can start to do with cognitive technologies. So what's coming is your ability to team to win. And the team is you and a computer. Man-machine symbiosis. So it's just around the corner, if it's not already here in many cases. And for some of you, the healthcare options, for some of you, for some parts of the world, Watson Health, oncology advisor, will make a massive difference. Will make a massive difference. And for those of us in the computing industry, and for some of us who have been here for a long time, that is one of the greatest things I think we can do. And that is within your grasp. And no matter what industry you're in, you provide data. Whatever industry you're in, you have loads of data. You have data about your clients, you have data about your systems, you have data about their environment. You can help predict what is best for them. What is best for them is an interesting topic, and one that David and I often talk about, which is making IT good for society. Okay, so what is best for them comes down to transparency in what you're doing, transparency in making sure people who use these systems and don't abuse them, and the people, the end users, understand them. It comes down to transparency, and it comes down to good governance. At the end of the day, your brand will depend on you behaving well with the data that you are using. But you have the ability to do many things that you've never done in the past. And teaming to win is something that I would say is what is coming. So, thank you very much.